In this video, we will be studying double replacement reactions. The essential questions that we'll be looking at are, how can I predict the products of a chemical reaction, and how can I predict whether or not a chemical reaction will take place? By the end of this video, you should be able to predict the products of a double replacement reaction and predict whether or not a double replacement reaction will occur. Double replacement reactions are sometimes called ion exchange reactions. In a single replacement reaction, we had an element plus a compound forming a different element and a different compound. In double replacement reactions, we have two compounds on the reactant side and on the product side. The two anions and two cations are going to switch partners, and we'll end up with two different products than what we started with. The ions do not change their charges in a double replacement reaction. Whatever charge they had on the left, they must have on the right as well. When you're doing these reactions, keep in mind that every compound you write must have a positive and a negative ion paired up. You can never have two positives or two negatives together. To determine whether these reactions actually take place, we need to look at the ionic compounds that are formed. Remember, ionic compounds tend to dissociate or break apart into the individual ions when they are in water. And all of these reactions that we're going to be dealing with are with aqueous solutions. So if you take a look at the reaction silver nitrate plus sodium chloride, the silver nitrate is going to break up in water into silver ions and nitrate ions, and the sodium chloride breaks up into sodium ions and chloride ions. On the product side, we would have silver chloride and sodium nitrate when we end up switching the ions. Sodium nitrate is a water-soluble compound, meaning on the product side, the sodium and nitrate have also dissociated. However, silver chloride is an insoluble compound, so the silver and chloride ions will be sticking together. In order to figure this out, you're going to need to look at the solubility guidelines for aqueous solutions in Table F of your reference table. If we look at this, halides, such as chlorides, tend to be soluble, but silver is an exception, so silver chloride will be insoluble, meaning silver chloride is a precipitate. So, in order for a double replacement reaction to occur, we need to either form a precipitate, an insoluble compound, or a covalent compound, because covalent compounds do not break apart into their ions when they're in water. So, just like we saw with the last one, silver nitrate and sodium chloride, to figure out what the products will be, I know that I have sodium is my positive, silver is my positive. Those two are going to be paired differently, which means the silver needs to end up with the chlorine. So Ag goes with Cl. This is a compound, so to find the subscripts, I would look up the charges. Silver is always +1, chloride is always -1, so it is just AgCl, plus the sodium ends up with the nitrate. For subscripts, sodium is +1, nitrate is -1, so this is just NaNO3. Those are the two products that would form. Now, to determine whether this will take place or not, again, we're going to check Table F. Chlorides tells me tend to be soluble, but silver is an exception. So that means silver chloride is going to be my precipitate. Sodium nitrate, sodium, anything in group 1 will always be a soluble compound. Most of the ions listed on Table F are anions. There are a few cations listed as well. If both ions are listed, it doesn't matter which one you look up. You will get the same answer either way. So like we said, all sodium compounds are always soluble. There are no exceptions. But we would get the same answer if we looked up the nitrate as well. Nitrate ions are also always soluble. There are no exceptions to that. So sodium nitrate is soluble. Because I'm forming at least one precipitate, this reaction will take place. Now I have lead chloride plus hydrogen sulfate. My positive ions would be the lead and the hydrogen. So I need to switch those two, which means the lead is now going to be combined with the sulfate. So Pb goes with the sulfate polyatomic ion. For the subscripts on this, sulfate, remember you can look up the charges for polyatomic ions on table E. Sulfate is a -2 charge. Lead has a couple of possibilities, but remember the ion cannot switch charges from the left side to the right side. So if I look on the left side, I know that my chlorines have a -1 charge. There are 2 of them, so it's a total -2 charge, which means my lead must be a +2 charge. So I have a +2 charge on the lead, a -2 charge on the sulfate. PbSO4 is my product. Plus, now my hydrogen is going to combine with my chlorine. So I have hydrogen with the Cl. Hydrogen forms a +1 charge. Chlorine forms a -1 charge. So I will end up with just HCl. To determine whether or not this will actually take place, I need to look up my ions. PbSO4. SO4 tend to be soluble compounds, but lead is an exception, which means that PbSO4 will become my precipitate. HCl is also a covalent compound, so both of those make it actually take place. However, I only need either one covalent compound or one precipitate, or both of them could be as well. Now this one isn't balanced, so to balance it I would go through and double check coefficients. Just putting a 2 in front of the HCl ends up balancing this equation. Next we have barium carbonate plus calcium nitrate. So my positive ions, I have barium and calcium. These are going to switch partners, so the barium ends up with the nitrate. So barium with the NO3. Looking up the charges, barium forms a +2 charge. Nitrate is a -1, so I'm going to need BaNO3 2. Plus calcium ends up with the carbonate. Calcium is a +2 charge, carbonate is a -2, so I don't need any subscripts on that. Double checking for balancing, there's the same number on each side. This one ends up balanced with just coefficients of 1 on everything. To determine whether it will take place or not, both of these are ionic compounds, so they're no covalent. I need to look up the ionic compounds here. Nitrate, NO3, forms soluble substances always. There are no exceptions. So barium nitrate is soluble. Calcium carbonate, carbonates tend to be insoluble unless they're combined with a group 1 ion or ammonium, NH4, which calcium is not in group 1. So calcium carbonate will be a precipitate. So this reaction will take place. Okay, here we have HBr plus BaOH2. Hydrogen and barium are my positive charges, so they're going to switch places. H forms a +1 charge. It's going to combine with the OH, which forms a -1 charge. So HOH, hydrogen is +1, OH is -1, so just plain HOH, which we can also write as H2O. It's your choice which way you write that. Plus, the barium is now going to combine with the bromine. So Ba with Br. Barium forms a +2 charge. Bromine is -1, so it's going to be BaBr2. I do need to balance this. We're going to save the hydrogens for the end because that's in both of my reactants. But I have one barium, one bromine on the left, but 2 on the right, which means I need to put a coefficient of 2 here. And then if I look at my oxygens, I have 2 oxygens on the left, so a coefficient of 2 here, which gives me 4 hydrogens on the right. There are 2 over here and another 2 here, so 4 on the left as well. For whether or not this will take place, the HOH is a covalent compound, and BaBr2, bromine tends to be soluble. Barium is not an exception, so BaBr2 will be a soluble compound. Next we have AgNO3 plus AlCl3. Silver and aluminum are my 2 positive ions, so the silver ends up with the chlorine. Silver has a +1 charge, chlorine has a -1 charge, so crisscrossing I just get AgCl. And then I have aluminum is going to end up with the NO3. When I crisscross that, aluminum has a +3 charge, nitrate has a -1, so it's AlNO3, 3. When I go to balance, there's 1 aluminum on both sides. There's 3 chlorines on the left, only 1 on the right, which means I need a coefficient of 3 here. For silvers, 3 silvers over here now, which means I need a 3 here, which also gives me the 3 nitrogens and the 9 oxygens that I need. Again, to determine whether this will take place or not, chlorides tend to be soluble, but silver is an exception, so AgCl will be a precipitate. Aluminum nitrate, nitrates are always soluble, there are no exceptions to that, so aluminum nitrate will be soluble. So when you are doing double replacement reactions, remember both of your products are compounds, which means you need to crisscross to find the subscripts. If it's things that can form more than 1 charge, whatever charge it had on the left, it must also have on the right. Then check your coefficients to balance it, and then these reactions will only take place if you form an insoluble substance or a covalent compound. That's because if both of your reactants start out as soluble, the ions have broken up into the individual ions. If both of your products are soluble as well, they stay broken up into the individual ions. Overall, nothing happens. So these will only take place if you form a precipitate, which you can figure out based on Table F, or a covalent compound.